Hey everyone, welcome back. Today we're diving deep into some research, and it's pretty cutting edge.
Yeah.
It could change the way we create and experience 3D worlds.
Definitely.
We're talking about a paper called Material Anything, and yeah, the name is pretty spot on.
I think so.
It's all about generating realistic materials for any 3D object.
Yeah.
Automatically.
It's really cool.
Imagine the possibilities.
Yeah.
Hyper-realistic video games, incredibly immersive VR,
Yeah.
even lifelike product prototypes, all without the painstaking work of manually creating materials.
It's a game changer.
Really is, yeah.
It is a huge leap forward.
Yeah.
Creating realistic materials has always been one of the biggest bottlenecks in computer graphics.
Yeah.
It requires a lot of artistic skill.
Yeah.
It's time consuming and it's difficult to get right.
Right.
Especially when it comes to making those materials look natural under different lighting conditions.
Yeah. Okay. So let's unpack this. I know from my very limited experience with 3D modeling that getting materials to look right is tough.
It is.
What are some of the problems with the traditional approaches?
Well, one of the biggest issues is that traditional methods often bake lighting into the texture itself. So if you move an object or change the lighting in the scene, the material suddenly looks off.
Oh.
It's like trying to use a photograph of a leather couch taken in a brightly lit showroom to represent that same couch in a dimly lit living room.
Right.
The lighting is so different that the material just doesn't look believable anymore.
Yeah, that makes sense. So it's not just about creating a texture.
Right.
It's about creating a material that responds realistically to light. Right.
Exactly.
Okay.
And that's where physically based rendering, or PBR, comes in.
Got it.
PBR is all about simulating how light interacts with different surfaces based on their physical properties. It's the gold standard for achieving realism in computer graphics these days.
Yeah.
But even with PBR,
Yeah.
creating those material definitions is still a very manual and time-consuming process.
And that's where Material Anything comes in.
Right. The researchers behind this paper are trying to solve that problem with a completely new approach.
Yeah.
They're using a type of AI called a diffusion model to generate those PBR material definitions automatically. Think of it like this: instead of an artist painstakingly crafting each element of a material, this AI learns to do it by analyzing thousands of examples.
So it's learning by example.
Yeah.
Almost like an apprentice learning from a master artist.
That's a great analogy.
Okay.
And what's really fascinating is that it can learn from imperfect examples, too.
Okay.
Traditional methods often assume that the lighting in the input images is perfect.
Right.
But in the real world,
Yeah.
that's rarely the case.
So how does this Material Anything system handle that?
Yeah.
Because I can imagine that inconsistent lighting would throw things off pretty badly.
It does. And that's one of the things that makes this research so innovative.
Okay.
They've built in something called confidence masks,
Okay.
which basically tell the AI how much it should trust the lighting information in each image. If the lighting is wonky, the system can rely more on the object's shape and other visual cues to figure out the material properties.
That's incredibly clever. It's like the AI is developing a sense of what's off about the lighting and then compensating for it.
Exactly.
Wow.
And the results are really impressive.
Okay.
They've shown that this system can generate high-quality PBR materials for a wide variety of objects, even those with complex shapes and textures.
Okay. I'm definitely intrigued.
Yeah.
Let's dive into how this whole process actually works.
Okay.
What's the first step?
Well, the first thing that the system does is analyze images of the 3D object from multiple viewpoints. It's like taking photographs of the object from all angles to get a complete understanding of its shape and surface.
So it's building up a 3D model of the object in its mind, so to speak.
Precisely.
Okay.
And once it has that 3D model, it uses a special neural network architecture to generate separate maps for different material properties like color, roughness, and how metallic the object looks.
Got it.
These maps are essentially the building blocks of a PBR material.
So it's breaking down the material into its individual components.
Yeah.
Kind of like a recipe for how that material should look and behave under different lighting conditions.
That's a great way to put it.
Yeah.
And it's doing all of this automatically.
Okay.
Based on the images it has analyzed.
Right.
No human artist needed.
That's amazing.
Yeah.
But those are just individual pieces of the puzzle.
Right.
How does it bring them all together to create a seamless material that covers the entire object.
That's where the second stage of the process comes in.
Okay.
The system takes those individual material maps and essentially stitches them together to create a unified material that wraps around the entire 3D object.
Okay.
And it does this progressively, starting with one view and gradually adding more, making sure that everything blends smoothly.
It's almost like wrapping a present.
Yeah.
Carefully folding and smoothing the paper as you go to make sure everything lines up perfectly.
I like that analogy. And to make sure there are no seams or gaps in the final material.
Right.
They use a special UV space material refiner. It's like having a digital tailor come in and make sure the material fits perfectly over the 3D object.
Okay. I'm starting to see how this all comes together.
Yeah.
But before we get too far ahead of ourselves, let's talk about the data they use to train this AI.
Right.
Because I imagine you need a lot of examples.
You do.
To teach a system how to create realistic materials.
You're absolutely right.
Yeah.
They created a massive data set called Material 3D, which contains over 80,000 high-quality 3D objects with detailed PBR material definitions. They were very careful to select objects that represented a wide range of materials and shapes, so the AI could learn to generalize its knowledge.
So it's not just learning to create materials for specific objects, it's learning the underlying principles of how materials work in general.
Exactly.
Okay.
And that's one of the things that makes this approach so powerful.
Yeah.
It's not limited to the specific objects it was trained on.
Right.
It can generate materials for any 3D object.
Wow.
Even ones it's never seen before.
Okay, I'm officially blown away.
Yeah.
This is some seriously impressive stuff.
It is.
And I can already see how this technology could have a huge impact on so many different industries.
Absolutely.
This is definitely one of those moments where you can see the future taking shape. But before we get too carried away with the possibilities, let's take a closer look at how material anything stacks up against existing methods.
Okay.
What are the key advantages that make this approach so groundbreaking?
Well, for starters, it's fully automatic. Okay. That means anyone can use it to generate realistic materials even if they don't have any artistic skills or experience with 3D modeling.
So it democratizes the process of creating realistic 3D content.
Exactly.
Wow.
It removes the technical barrier and empowers anyone to create visually stunning 3D experiences.
Right.
And on top of that, it's incredibly fast.
Right.
Traditional methods can take hours or even days to create a single material.
Right.
But material, anything can do it in minutes.
That's a huge time saver, especially for industries where speed is of the essence.
Right. And we can't forget about the quality.
Right.
The materials generated by Material Anything are incredibly realistic.
Yeah.
Thanks to its use of PBR principles and its ability to handle complex lighting conditions.
So it's a win-win-win.
It is.
Faster, easier, and better quality.
It really is.
Wow.
And the researchers have done a great job of demonstrating those advantages in their paper.
Okay.
They compared Material Anything to a number of existing methods and showed that it consistently outperforms them in terms of speed, accuracy, and realism.
Okay, I'm convinced this is a game changer.
Yeah, it is.
But let's get into some specifics.
Sure.
Can you walk me through some examples of how Material Anything outshines those older techniques?
Sure. Let's start with traditional texture generation methods.
Okay.
These methods often create textures with unrealistic lighting artifacts that just don't look right.
Right. So even if you nail the texture itself, it might still look flat and unconvincing under different lighting.
Exactly.
Okay.
And then there are optimization-based methods, which are notoriously slow and can't always capture the right material properties.
And we can't forget about retrieval methods.
Right.
Which often miss fine details and struggle with shadows.
Right. And Material Anything tackles all of those problems head on.
Okay.
It delivers realistic, high-quality materials.
Yeah.
Regardless of the complexity of the object or the lighting conditions.
That's amazing. It sounds like they've truly cracked the code for generating realistic materials.
It's definitely a major breakthrough.
Yeah.
And I think it has the potential to revolutionize the way we create and experience 3D content.
Because let's shift gears a bit and talk about some of the potential applications of this technology.
Okay.
Because I could already imagine a ton of exciting possibilities.
Absolutely.
Yeah.
One of the most obvious applications is in video games. Imagine being able to create incredibly detailed and realistic game environments.
Yeah.
With just a few clicks.
It would free up game developers to focus more on gameplay and storytelling.
Right.
Without having to spend countless hours on tedious material creation.
Exactly.
Yeah.
And gamers would benefit from more immersive and visually stunning experiences.
And it's not just limited to video games, right?
Well, not at all.
Yeah.
Material anything could also revolutionize the world of VR.
Yeah, definitely.
Imagine being able to step into a virtual world that looks and feels just as real as the physical world.
That would take VR to a whole new level of immersion.
It would.
Oh.
And it could have a huge impact on fields like education and training, allowing people to learn and practice in realistic, simulated environments.
And I can see this being a game changer for product designers, too.
Oh, yeah?
They could quickly prototype different designs and see how they look and feel with different materials, all without having to create physical mock-ups.
Exactly.
Yeah.
It would streamline the design process and allow for more experimentation and innovation.
And what about architecture?
Definitely.
Architects could create incredibly realistic virtual tours of buildings, allowing clients to experience a space before it's even built.
It would be a fantastic tool for visualization and communication.
The possibilities are truly endless.
They are.
But I'm also curious about what this technology means for the future of art. Could material anything change the way artists create and experience art?
That's a great question.
Yeah.
And I think the answer is a resounding yes. Artists could use material anything to create incredibly realistic sculptures and installations, pushing the boundaries of what's possible in the digital realm.
And it could open up new avenues for artistic expression, allowing artists to explore the interplay of light and material in ways that were never before possible.
It's an exciting time to be an artist.
I couldn't agree more.
Yeah.
This technology has the potential to transform so many aspects of our lives.
It does.
But as with any powerful technology, it's important to be mindful of the potential implications.
That's right.
Yeah.
As this technology becomes more widespread, it's crucial to ensure that it's used responsibly and ethically.
Right.
We need to be aware of the potential for misuse, such as creating misleading or harmful content.
That's a valid concern, but I'm also optimistic about the potential for good. This technology could empower people to create and experience incredible things, and I'm excited to see how it shapes the future.
Me too. It's definitely a technology to watch.
Well, folks, that brings us to the end of part 1 of our deep dives into material anything.
Okay.
We've covered a lot of ground, from the technical details to the potential applications and implications of this groundbreaking technology.
It is groundbreaking.
But we're not done yet. In part 2, we'll take an even closer look at how this system works, exploring the inner workings of diffusion models and the clever techniques used to create such realistic materials.
Sounds good.
So stay tuned for more.
You know, one of the things that really struck me about this material anything research is how they tackled the challenge of inconsistent lighting.
Yeah, we touched on that earlier, but I'm still a bit fuzzy on how they actually make that work.
Yeah.
It seems like it would be a major roadblock for any system trying to learn about materials from images.
It definitely is. Think about it.
Yeah.
Even in the real world, the way an object looks can change dramatically depending on the lighting.
Right.
A smooth, shiny surface might look dull and rough in dim lighting. Or a colorful object might appear almost monochromatic under a strong, single-colored light source.
Right. So how does the AI know what to trust?
Yeah.
When the lighting information is all over the place?
That's where those confidence masks come in.
Okay.
It's like the AI has a built-in lie detector for lighting.
Okay.
It can analyze each image and figure out which parts of the lighting information are reliable and which parts are suspect.
Okay, so it can tell when the lighting is throwing things off.
Right.
But how does it actually correct for that?
Well, it uses a couple of clever techniques.
Okay.
First, it leverages the power of a pre-trained image diffusion model.
Okay.
Now, these diffusion models are amazing tools.
Yeah.
They're used in all sorts of AI applications, from generating photorealistic images to creating stunning works of art.
I've heard of those. They're the ones behind those AI image generators that have been making headlines lately, right?
Exactly. And in this case, they're using a diffusion model that has already been trained on a massive data set of images, So it has a deep understanding of how light interacts with different materials.
So it's like the AI has already learned a lot about lighting and materials from its previous training?
Yeah.
And it can apply that knowledge to this new task of generating PBR materials.
Precisely. But here's the catch.
Okay.
Diffusion models typically work with RGB images, which only capture color information.
Right.
PBR materials, on the other hand,
Yeah.
are defined by multiple channels, including color, roughness, metallic properties, and bumpiness.
So it's like trying to fit a square peg into a round hole.
In a way, yes.
Yeah.
But that's where the ingenuity of this research comes in.
Okay.
They figured out a way to bridge that gap by using a special neural network architecture called a triple head network.
Triple head network.
Okay.
You've officially lost me.
Okay.
Break that down for me like I'm 5 years old.
Okay. Imagine you have 3 artists, each specializing in a different aspect of painting.
Oh.
One focuses on color, one on texture, and one on shadows and highlights.
Got it.
They're all looking at the same subject,
Yeah.
but they're each capturing different information about it.
Okay. I'm following so far.
Well, the triple head network is kind of like that.
Okay.
It has 3 separate branches, each responsible for generating one of those PBR material channels.
Okay.
So one branch focuses on creating the color map, or albedo. Another branch handles the roughness map.
Okay.
And the third branch takes care of the metallic and bump maps.
So it's like dividing and conquering the problem.
Exactly. And by training this triple head network on a massive data set of 3D objects and their corresponding PBR materials, they've essentially taught it how to translate the knowledge of the image diffusion model into the language of PBR materials.
Oh, that's brilliant.
Yeah.
It's like they've taken this powerful tool, the image diffusion model, and adapted it to this very specific task of creating PBR materials.
Exactly.
That's really cool.
And the results speak for themselves.
Yeah.
The materials generated by this system look incredibly realistic, even when the lighting in the input images is far from ideal.
So it's not just about creating a texture, it's about creating a material that truly behaves like its real-world counterpart. Right?
Exactly. It's about capturing those subtle variations in how light interacts with different surfaces.
Right.
Those subtle nuances that make a material look and feel authentic.
Now, we talked earlier about how the system stitches together those individual material maps to create a seamless material that covers the entire object.
Right.
Can you walk me through that process in a bit more detail?
Sure.
Because I imagine that's not as simple as just pasting them together.
You're right. It's a bit more sophisticated than that.
Okay.
The process is called progressive material generation.
Okay.
And it's all about building the material up gradually, ensuring that everything blends smoothly and consistently.
So it's not just slapping the material on all at once.
No, it's more like carefully wrapping a gift.
Okay.
Starting with one side and gradually smoothing the paper around the object, making sure there are no wrinkles or creases.
I can picture that.
Yeah.
So how does this progressive generation actually work?
Well, the system starts by generating the material for one view of the object.
Okay.
Then it uses that information as a starting point for the next view. And so on.
Got it.
It's constantly building upon what it's already learned.
Okay.
Making sure that each new piece of the material fits seamlessly with the previous ones.
So it's like a painter working on a canvas.
Right.
Adding one brushstroke at a time.
Yeah.
Blending each new color with the ones that came before.
Exactly.
Yeah, cool.
And to make sure the material is applied consistently across the entire object. The system relies heavily on those confidence masks we talked about earlier.
Right.
The confidence masks help the system identify which areas of the material are already well defined and which areas need more attention.
So it's constantly checking its work, making sure that everything is lining up correctly.
Precisely. And if a particular region has already been accurately generated in a previous view, the system can focus its efforts on other areas that might be more challenging.
It's all about optimizing the process for both speed and accuracy.
Exactly.
Yeah.
And this progressive approach is a big part of what makes material anything so robust.
Right.
It can handle complex object shapes and inconsistent lighting conditions without breaking a sweat.
But even with all that careful blending and stitching,
yeah,
I imagine there might still be some rough edges or seams in the final material.
Right.
How do they address that?
That's where the UV space material refiner comes in.
Okay.
It's like the final polish that makes the material truly shine.
Okay, remind me again what a UV map is.
It's basically a 2D representation of a 3D object's surface.
Good.
Think of it like taking a piece of clothing and laying it flat on a table. The seams and darts that give the clothing its 3D shape are all represented in the flat pattern.
So the UV map is like the blueprint for the material.
That's a great way to put it.
Okay.
And the UV space material refiner is like a master tailor.
Right.
It takes that blueprint and makes sure all the seams are perfectly aligned. And any wrinkles or imperfections are smoothed out.
So this is where they fix any lingering issues with seams or gaps in the material.
You got it. The refiner uses a diffusion model specifically trained to clean up these artifacts.
Okay.
It analyzes the UV map and uses its knowledge of how materials should behave to make subtle adjustments, ensuring that the final material is seamless and consistent.
It's like the final touch that elevates the entire process to a whole new level of quality.
Exactly. And the result is a UV map that can be easily used in any 3D modeling or rendering software.
Wow.
It's incredibly versatile and incredibly realistic.
This is all just mind-blowing. It sounds like they thought of everything.
They really have. And I think the beauty of this approach is its simplicity. They've taken some very powerful AI tools, like diffusion models, and combined them in a clever and innovative way to solve a problem that has plagued computer graphics for decades.
And they've done it in a way that's both elegant and effective.
Exactly. And the implications are huge.
Yeah.
We're talking about a potential paradigm shift in how we create and interact with 3D content.
It really is.
But before we get too carried away with the possibilities, I think it's important to ground ourselves in the realities of what this technology can and cannot do.
That's a good point.
Yeah.
What are some of the limitations we should be aware of?
Well, for starters, even though this system is a major step forward, it's not perfect.
Okay.
There are still some challenges that need to be addressed.
Yeah.
For example, while it does a great job of generating overall material properties, it can sometimes struggle with very fine-grained details.
Okay.
Like the subtle texture of a woven fabric or the intricate patterns on a butterfly's wing.
So there's still room for improvement when it comes to capturing those intricate details.
Absolutely.
Okay.
And another thing to keep in mind is that the quality of the generated materials is still dependent on the quality of the input images.
Right.
If the input images are blurry or poorly lit,
Yeah.
the generated materials might not be as realistic.
So garbage in, garbage out, as they say.
To a certain extent, yes.
Yeah.
But even with those limitations, material anything is a remarkable achievement.
It really is.
And I think it represents a major step towards a future where creating realistic 3D content is as easy as taking a photograph.
I can't wait to see what they come up with next.
Me too.
But for now, I think it's time for us to take a little break.
Okay.
When we come back, we'll dive into some of the broader implications of this technology.
Sounds good.
And explore what it means for the future of 3D content creation. Welcome back. I don't know about you, but I'm still reeling from all that technical wizardry we unpacked in part 2.
Yeah. It's
amazing to think that we're now at a point where AI can learn about materials in a way that almost mimics human perception.
It is pretty remarkable. The way material anything leverages those confidence masks to handle inconsistent lighting is a real testament to the ingenuity of the researchers.
Yeah, I'm curious.
Yeah.
Do you think this approach could be applied to other areas of computer graphics?
Oh, absolutely.
Beyond just material generation?
I think the underlying principles of this research have the potential to revolutionize a wide range of applications.
Okay.
For example, imagine using confidence masks to improve 3D reconstruction from photos or videos. You could train an AI to recognize and compensate for things like lens distortion, motion blur, or even occlusions.
That would be huge for fields like robotics and autonomous driving, where accurate 3D perception is crucial.
Exactly.
Yeah.
And in the realm of special effects, you could use confidence masks to create more realistic and seamless compositing. Imagine blending CGI characters or objects into live action footage in a way that's virtually undetectable.
The possibilities are endless. But let's bring it back to material anything for a moment.
Okay.
We've talked a lot about the technical side of things.
Yeah.
But I'm also fascinated by the potential impact this technology could have on various industries.
Well, as we touched on earlier, the gaming industry is an obvious candidate.
Right.
Imagine being able to create incredibly detailed and realistic game environments with a fraction of the effort and time currently required.
It would be a dream come true for game developers.
They would.
They could spend less time on tedious tasks like material creation and more time on things like gameplay mechanics and storytelling.
Exactly.
And gamers would benefit from more immersive and visually stunning experiences.
Absolutely.
Imagine exploring a vast open world where every object from the rocks and trees to the buildings and vehicles looks and feels incredibly lifelike.
Yeah, and it's not just about realism, right?
Right.
This technology could also open up new avenues for artistic expression in games. Yeah. Game designers could experiment with new and imaginative materials, creating worlds that are both beautiful and believable. They could even use material anything to procedurally generate materials, creating environments that are constantly evolving and changing.
And what about the film industry? I can see this technology being a game changer for visual effects.
Oh, definitely. Creating realistic materials is one of the biggest challenges in visual effects.
Yeah.
And material anything could automate a lot of that process.
Right.
Imagine creating photorealistic CGI characters that blend seamlessly into live-action footage. Or designing fantastical creatures and environments that look and feel completely believable.
It would free up visual effects artists to focus on the more creative aspects of their work.
Exactly.
Like animation and compositing.
And it could lead to a new wave of innovation in filmmaking.
Yeah.
Allowing directors to bring their wildest visions to life.
And beyond entertainment, I can see this technology having a huge impact on fields like product design and architecture.
Excellent.
Product designers could use material anything to quickly prototype different designs.
Right.
And see how they look with different materials, all in a virtual environment.
Yeah.
They could test out different finishes, textures, and colors without having to create expensive physical mock-ups.
Exactly.
It would be a huge time saver and would allow for more experimentation and iteration in the design process.
It would.
And architects could create incredibly realistic virtual walkthroughs of buildings, allowing clients to experience a space before it's even built.
But they could even simulate different lighting conditions and materials to see how they affect the overall look and feel of the space.
It would revolutionize the way architects communicate their designs.
For sure.
And would give clients a much better understanding of what they're getting.
And let's not forget about the potential applications in education and training.
Oh, yeah, definitely.
Imagine using material anything to create realistic simulations for everything from medical procedures to flight training.
Yeah, that would be incredible.
Students could learn and practice in a safe and controlled environment, gaining valuable experience without any real-world risks.
And the simulations could be tailored to individual learning styles and needs.
Absolutely.
Creating a more engaging and effective learning experience.
It's amazing to think about all the ways this technology could be used to improve our lives.
It really is.
But as with any powerful tool, it's important to consider the potential downsides as well.
You're absolutely right. One of the biggest concerns is the potential for misuse.
Yeah.
As this technology becomes more widespread, it's crucial to think about how it could be used to create misleading or harmful content.
For example, someone could use material anything to create incredibly realistic deepfakes.
Right.
Making it even harder to distinguish truth from fiction.
That's a valid concern.
Yeah.
And it highlights the importance of developing safeguards and ethical guidelines for the use of this technology.
Definitely.
We need to ensure that it's used responsibly and for the benefit of society. And we also need to be aware of the potential impact on jobs.
Yeah.
As this technology automates certain tasks.
Right.
It's possible that some jobs in fields like 3D modeling and texturing could be displaced.
That's a legitimate concern.
Yeah.
But I also think it's important to remember that new technologies often create new opportunities as well.
That's true.
As material anything frees up artists and designers from tedious tasks, it could allow them to focus on more creative and strategic work.
It's like the shift from manual labor to automation in manufacturing.
Exactly.
It led to job losses in some areas, but it also created new industries and new types of jobs.
Exactly. And I think we're likely to see a similar trend with the rise of AI in creative fields.
Yeah.
The key is to adapt and evolve with the technology, embracing the new possibilities while mitigating the potential risks.
Well said. I think that's a great note to end on.
I agree.
It's been a fascinating journey exploring the world of material anything with you.
Yeah, it has.
We've covered a lot of ground from the technical intricacies to the potential applications and implications of this groundbreaking technology.
It's been a pleasure. And I think it's safe to say that the future of 3D content creation is looking incredibly bright.
Yeah.
Thanks to innovations like material anything.
I couldn't agree more. And to our listeners, we hope this deep dive has sparked your curiosity and left you with a sense of wonder about the possibilities that lie ahead.
I hope so.
Keep exploring, keep learning, and who knows what amazing discoveries await us in the future.
Definitely.
Until next time.